So here I'm having exactly as every time, the Spark session and the Spark context, although this time I'm not really going to use the Spark context because we're not creating RDDs anymore. We're going to use something called Dataframes. Now, Dataframes, the concept of it is available in different places. Like, it's not something Spark invented. So Dataframes are well known in the R programming language. The whole like Dataframes are part of the actual language. It's like a data object in the language. Pandas library also is very popular library in Python for data analysis. And like Pandas is all about its Pandas data frame. So you might have heard that term before. And the data frame in Spark follows very similar concept to other data frames, which means that the skills that you will gain here do not have to be only used in Spark. They can be used in many different places where you're dealing with data analysis. So now, when we said about RDDs that they are unstructured, we saw what it means to be unstructured. With data frames, we're dealing with structured data. Like, we're dealing with basically a table, like similar to an Excel sheet or an SQL table. We have columns, we have rows, we have headers, which means loading a file depends on what type the file is. So in here, we're using the Spark session at this point. It's not the Spark context anymore. We're using the Spark session to load, like Spark session is used to create data frames. And we are specifying from the read.csv, because we are reading a CSV file. And we are specifying the file, which is ratings of CSV. And I'm specifying that we have a header. So header equal true. So the first line will be used as the header. And this is being loaded to a data frame that I'm calling df ratings. Now, the concept of everything you do is similar to RDD in the sense that data frames are actually using RDDs in the back, like in the behind the scenes. So the data is stored in RDDs and the process is all processing in RDDs, which means that the lazy evaluation of RDDs still work fully. Now, we can show the data, like we can show the data frame, sorry. And by showing the data frame, well, we have now, like, it's actual data now. It's not just elements with strings, right? It read the file, it abstracted the columns and the rows, and it identified also that these are numbers, and we have them as numbers. And the show function takes a parameter that is n. Actually, if you do like shift tab inside of it, you can see the signature of, like, the notebook will show you the signature of the function and any documentation it has. So here it takes the default value is 20 rows that it will show us, and then there's like truncate and vertical, which like you usually never use. You just keep it like this. So if I choose 3, for example, we're only going to get 3 rows. Now, again, data frames have RDDs. RDDs is like, it's using RDDs for the data, actually, like to process everything, to display everything. And you can access the RDD for every data frame. So this is my data frame, and I can do .rdd, and this gives me the behind the scene RDD that is saving the data. Now, if I look at it, you can notice that it's actually a bit different than when we load the RDD, because some processing has happened already here. And there's some, like, the elements of the RDD is of the class row, which comes from the Spark library. So there's already some processing that happened to the RDD. And this is the element of every RDD, which, when you're dealing with data frames, like in some cases, you would access the hidden RDD and do some mapping and processing on it. But most of the time, well, you don't want that, because it's just pain, basically. Like you want to deal with this kind of structure over the RDDs that we have been working with. So now, to read data from the data frame, we can use the select. And the select can specify like the columns that we want. So this is the data frame. I can use the select and I can pass the name of the column. So in this case, it's the user ID. And I can call show on it. And now I have just this one column. I can pass multiple columns, user ID and movie ID. And remember that this, like the select here, is going to return a new data frame. So I can save it and do something with it. But in this case, I'm just showing it. Now, what is a column? A column is just an indication kind of like the name of the column, and even sometimes you can specify operations that you want to do on the column. So a column can be returned just by having the data frame that you have dot the name of the column. So in this case, the return of this would be a column that has the name movie ID. Now, a column does not hold the actual data. It's just information about an existing column. Even if it's not existing, like it can be, we'll see now, it can be just a column that you create. So this is one way to get the column of movie ID from this data frame, which is, again, it's not the actual data of the column, it's just the information of the column. We can also use the data frame with this, like similar to how you treat dictionaries, kind of. So we specify a string here for the column and it returns the same exact thing. Now, this is what's interesting. From the PySpark SQL functions at the beginning here, I am importing column, ascending, and descending. So these are functions from the library, from the PySpark SQL.functions. So if I call the function column and just pass a string to it, it's going to create a column that is basically identical to these. Because the thing about column, again, is that it's not holding any data, it's just description of a column. So in this case, all of these are describing a column that has the name movie ID. And this is something that you would use a lot in the actual processing. So now, inside the select method, we need to select the column that we want to be selecting. So we can do on the data frame dot select, and we can get the column like this from the data frame itself dot the name of the column. This will return, this is exactly like this, and it will return the column, and it will be passed to the select, and then we can show it, and we're getting the two elements of this column. We can also pass the column this way, which is using the data frame and then accessing the data frame as a dictionary, which will get us the column. This is exactly the same. And we can pass a column that we create just with the name. This is coming from nowhere related to our data frame. This is just coming from us. We are creating a column object here that is having this name, and we're passing it to the select. So this will be matched with the columns in the data frame, and it will be selected based on that. If you specify like ID capital D and you try to do this, okay, it works, but it shouldn't have. Okay, so it's the same, cannot resolve movie IDs given input column movie ID rating timestamp user ID. So it needs to have the name of the column to be able to access it. Now, what's also interesting is that with columns, you can do like expressions on the column. Like you can do arithmetic operations, you can do Boolean operations on the column itself, and it will only be processed once it gets added to a select function, for example, or a function that is taking a column as a parameter. In other words, right here, I'm creating a column with the name movie ID, and I'm adding this number to it. If I execute this, this is going to return to me a column that has the name movie ID with the process of this happening to it. And actually, it automatically created the name of it. So this is now the new name for it. But it basically kept track of what operations I did to it. So in other words, if I do select here with the column movie ID plus this number, what I get is a new column with the movie ID plus this number. So this is the actual data. This is similar to how you treat an SQL table. In the select of the SQL, you can be choosing the column name and adding something to it, and it will just process it. The difference here is that it gives it automatically a name. You don't have to do as something and give it a name yourself. It automatically gives it a name based on what you actually did. However, we can also give it an alias. So here we're creating the a column movie ID, adding to it this, and we're giving it an alias name of movie ID with addition. And then we are using all of this here inside the select. So if I run this, we get a new column that we selected here, which is the process of the column of the movie ID plus this number with an alias name of this. You have questions?
No, this makes sense, but are we supposed to have this notebook or not yet?
Oh, you don't have it. It's fine. Just keep going with me, and
Yeah, it makes sense.
Yeah, I'll upload it afterwards. But like today, even for sure, we're not gonna be able to finish all of it or start with the exercises. So, okay. So we can also do Boolean expression to the column. So in here, like column rating, because our original data has this. We have the user ID, movie ID, rating, and timestamp. So if I do the column that has the name rating equal 3, well, right now I'm not gonna get any data because I'm not even accessing data frame. I'm just specifying like what I want to have, a column of name rating. I want to compare that column with the number 3. So if I pass this to a filter function on the data frame, so this is my data frame, filter, and I specify this, like the filter to be the column named rating equal to 3, magically I get all the data that has in the rating equal to 3. And you can even like have, like you can combine conditions on these expressions. So in here I have, actually, I think I'm asking you, what is this below filter doing? So who can like analyze what this is doing?
You're refiltering for a column that has a rating bigger than 2 and a rating between 2 and 4. So it would be 2 and 4, or movie ID 1. That's or and yeah, that's or.
Yeah,
Is this this is and, but what is the other symbol?
This is or and this is and.
Okay, yeah.
And these are like binary operations. They're not Boolean operations like the and the or. But I think these should work. Let me see. Nope.
No.
Okay. So there's a reason why I use these. So this is like this part here saying that the ratings has to be greater than 2 or less than 4 is separated by these parentheses. So this or this, meaning what this will lead is that the rating is equal to 3, basically, because greater than 2 and less than 4 is going to just leave us with the 3. So we're saying that we want a movie that, like, actually we want to keep all the ratings that have a value of 3, unless the movie ID is equal to 1. We want to keep all of them. And that's why we see here the first movie had, like the first element we have, the movie ID is 1, and this is 4 rating, because this was passed as an or, and this was true. So this stayed, but the rest here, only the 3s stayed, because anything that is not 3 or anything that does not have a movie ID of 1 was filtered out. So this is how you deal with data frames. You're looking at the column and what do you want to do with that column, basically. And like it might be a bit weird first time you're dealing with it, but from my experience, it's a much like it makes so much more logic than RDDs. Like maybe not logic, but like easier to actually use and follow up.
Because there's you don't deal with arrays and keep track of the index of each.
Yeah, you're dealing with structured data. Like you can imagine a table and you can imagine the data. Before you're dealing with objects only, and you're the one responsible of translating every object to something else and having the key value pairs and whatever. Okay.
So for the the Boolean operations, it's always gonna go from left to right. So it wouldn't. Does it change anything if you put like certain parentheses? So let's say if you wanted to change it so that it would be every rating under 2, and then and this other part. I don't know if you know.
This works exactly as any expression, like Boolean expressions that you've dealt with all the time. So the order matters, of course. So this whole thing is in parentheses.
Yeah.
So this whole thing or this. But if you want to make this whole thing and something, we can, like here. So so if the column at rating is equal to 2, or is that what you wanted?
I don't know what I wanted. I was just wanted to make sure.
Yeah.
That
so if it is greater, like let's say equal to 2, but now we have some contradiction here, but it's okay. So if this is equal to 2 and all of this, we're going to be left with just the ones, because like just the movie ID ones, because if the column rating is equal to 2 and that's the only ones you are keeping, they will not pass from this, because this is only getting the ones equal to 3. So now at this point, you're only left with the ratings equal to 2. And why do we have rating 2.5?
Because it's you still get the ratings between 2 and 4, right?
Yeah, but does the rating actually have 2.5 in the data set? I didn't know that.
Yeah, there's some.
Okay. I thought just 2, 3, 4. Okay, so you're still getting these because it can be 2.5. Yeah, and you're getting the when the movie ID is equal to 1. Yeah, but the 2.5 shouldn't pass, because this is saying ratings is equal to 2 and this, right?
Oh, you're right.
Okay.
So since it's a float, I guess.
Yeah, because before it was an integer, so it was probably casting the column to an integer and doing the equal, and the 2.5 would pass.
Yeah, probably.
Now it wouldn't pass. Okay. Now you're gonna love the group by and the join, because they work like in a simple way. So here we have the data frame ratings that we started with, the original one. So let me just output it again. Just show it again. So far, we are still dealing with just one data frame. This is the data we have. Now, to group by, let's say we want to group by the movie ID. And like in here, we're trying to find the like how many ratings a movie has, or the average rated movie, like the average rating for movies. So we basically want to group by the movie ID. And it's as simple as doing the data frame.group by and specifying what column we want to group by. So in here, we are grouping by, on this data frame, we are grouping by the movie ID column. Now, this is exactly similar to if I do this, because remember, like it's just information about what column. It's not actually related to the data frame itself, but it, so this also, like this and that are the same thing. Now, the return of this is a object of what's called group data. So it's just part of the like PySpark thing, and it's a group data. So this is a data frame of type group data, and then we can apply to it like aggregate functions. So an aggregate function can be the count, for example. So in here, we're getting on the data frame group by the column movie ID, and the aggregate function is count. And we are storing this new data frame in this name data frame ratings count per movie. And if we show this data frame, here we have it. For every movie ID, the count of the ratings it has. So this is a lot of similar to how we've been dealing with SQL tables, kind of, because we are dealing with tables. In fact, with Spark, you can even access everything as SQL. Like there's literally, like here, there's an SQL in which you can write your SQL and process it. And you can give your tables and columns like alias names and deal with them as SQL, which I think we're not gonna get into it because we want to finish data frames and then move on with the course. But this is as some, like we just did a group by, specified what column we're grouping by, and then that group by that is happening based on the movie ID, what do we want to do with all the values? We're specifying to count. So it's counting how many occurrences it has, and we're getting this output. Now we can also filter the count, because now in this return, we have a new column in the data with the name count. So we can simply do filter the column count greater than 20 and show it. So now the counts, like in here, in the first 20 elements, we had a count of 9, 5, 8, and so on. Now we don't have them anymore. So now we filtered out the movie, like the count that are like the movies that had at least or more than 20 ratings. So now we want to join this data frame with something else. Actually, we want to join both data frames, like the ratings that we started with originally, with the movies data. Oh, no, sorry. We're joining, like we didn't get to the movies yet. We want to join this, the count, with the original data. Like for every movie, for every rating, we want to see the count next to it here. So this is the original data, and we want a new column that tells us the count for this movie, which means there's going to be some repetitions, but that's okay. So again, let's show the ratings. So if we do this ratings, data frame ratings dot join, we specify what other data frame you want to join with, which in this case, I'm specifying this one. Actually, this one, not the filtered, because this is not being saved anywhere, just showing how to do the filter. But this one, which has the counts of all the movie IDs. And I'm joining it based on a specific column. Like the column will decide how we're doing the join. And the thing is that it's as simple as this. We're specifying on this data frame, we're joining which data frame, this one, and on which column. So it's the movie ID column. Because these movie ID columns in this case matches the names. So they both have the same exact name. If they were a different name, we can specify a condition here, like where column movie ID is equal to column whatever. We can specify the condition in which it matches the columns. But in this case, the movie ID is the same name for both data frames. And now by doing this, we have the join. So on the ratings data frame, for every single movie, we are joining it with the count based on the processing that we did right here. Now you can notice we didn't have to join tuples or anything. It joined the columns because it's all structured as a table of data with columns and everything, which makes sense with most of the data that you would be analyzing and using, like, and most of the data in the world. But sometimes like data can be unstructured and RDDs would work. But this is more like user friendly and makes more sense. So the join, however, there are types of join, and they are very similar to the SQL join. So by default, it's the inner join, like it's doing an inner join. Do you know the differences between them?
I'm gonna be honest, I don't remember all the the SQL joins. I probably should, but yeah.
Okay, so the inner join is going to take like if it's going to map every movie ID with the other one, but if it doesn't find the movie ID in the other RTD, it's going to take out the whole row. So this is good for if you also want to filter some data, like you want to join, but also keep just the ones that you have in the in both RTD, in both data frames. If they exist in both data frames, they're gonna stay. If the key exists on only one of them, then the whole key is not going to stay. Now you have the outer join, I think, is it's going to just join exactly everything. So even if it exists only in one data frame, it's going to join it, but it's going to put null values for the rest of the elements. And you have left things and right things. So it will be like basically it will only join the ones on the if the right exists, but if the left exists, it will remove it, or if the left doesn't exist, it will put null value instead of it. So like you have like half between the inner and the outer.
Yeah, I see.
But mostly you'll be dealing with inner. Like that's usually the case where you will be dealing with inner joins, and it's the default one. So anyway, this is an inner join where we have now for every rating we have, for the movie ID, we have the count of ratings that it has. Now, if we want to sort this, we can order by something similar to the order by you deal with SQL. So this is the data frame. We called it ratings with count, and we can do order by, and we can specify the column that we want to order by. So in this case, it's the movie ID. And if we show it, now everything is sorted based on the movie ID. And you can see that we have the same count for all the movie ID with 1. And this is exactly what the join did. So the join for every movie ID in the ratings, it added the count to it that we've calculated before, which is repetition of data, but that's fine. It's just one column and it's not that big. So now we can apply the filter that we were dealing with before of count, having the column count greater than 20. And now we are applying this filter on this table here, on this data frame. So now we will be left with the ratings that only exist on the movies that have 20, like above more than 20 ratings. So here we had this movie, for example, with movie ID 157 that had a count of, so this is rating a movie that has count of 11. We shouldn't see it here anymore. It was filtered out. And now the data frame is called DF ratings filtered. So now if we order by the count, so we're basically sorting by the count, we're gonna get the least count 21, and that's exactly what we successfully filtered out the data. Now, there is a function called aggregate, AGG, which works really well to, like when you're doing group by, you want to specify how you want to aggregate, and you can use it a lot. Like this is a function that can be used a lot, in which you basically pass to it the, like, what do you want to do? Like, how do you want to aggregate? And you can pass multiple ones. Now, what happens if we aggregate a data frame that is not grouped? So if it's not grouped by anything, how many groups do we have in the data frame?
I'm not sure what you mean.
Well, if you have a table, okay, and you did not group it by anything, how many groups do you have?
Whatever the amount of rows is.
So you're saying that every single row is a group?
I guess, or one group.
Yeah, I would say the whole thing is one group because I did not group it by anything.
Yeah.
right? So as far as we know, the whole data belongs to one group. We did not specify any grouping by. So when you apply the aggregate data frame without group by, it's just going to aggregate the whole thing as one group, which is kind of similar to reduce. But we're not dealing with reduce. We're dealing with structured data in which you can aggregate on a specific column to get some specific result. So what we're doing here is that we're having this ratings filtered. So this is all the ratings, but with the count of it as an added column, and filtered out to have the ratings that are bigger than that have more than 20 count of ratings for that movie. And if we aggregate, here we specify in a dictionary like this the name of the column and the name of the like the function that we want to apply. So in this case, it is the count column and the minimum value. So what this result in is the minimum value of the count column. So this might be a bit not very programmatically kind of for someone who's coming from just program, like, you know, calling a function and stuff. This might not be very user friendly. So I personally prefer the other way of dealing with this. So there are functions from the SQL, like functions from PySpark that you can import. Like some of these functions are sum, maximum, minimum, average. And here you can, on the aggregate function, you can pass multiple columns and you can apply this function to a column. So in this case, I'm applying the maximum function to the column count. So what this will return, if I just run this separately, so maximum on the column count. Okay. This works here though, right? No? Oh. Okay. Because it was using the max from Python and not the one I'm importing here. So that's why it was getting an error. So now you have to import this. So if I apply just the max function and pass column to it like this, remember this column doesn't actually represent any data whatsoever. It's just the name of a column. So the returned value is a column object that has the like memory of what was processed on it, kind of. So this was what was processed on it is the maximum of this column. And it has a new name actually, which is max count. So the aggregate expects columns to be passed to it. And if I pass a column that has some processing on it, then it will be processed in the aggregation. So here I'm passing the maximum of column count, minimum of column count, average of column count, minimum column rating, maximum of column rating, and the average of column rating. And I'm showing the return data frame. And just like this, we process many things on our full table data. So the reason aggregate here is working on the full data is because we did not group by anything. So the whole data frame is one group. And any function we are using here is basically being processed on the full group. How much of this made sense?
Yeah, all of it.
Okay, that's good. I'm assuming you're already seeing why this is more user-friendly than RDDs.
Yeah, we're basically getting all of that. All of that information is about the whole data frame.
Yeah, and you're treating everything based on the columns. Like you don't have a full, like you're not looking at it as rows anymore, like you do with RDDs. Now you have columns and you're processing things based on the column.
Yeah.
It's more organized.
Yeah, exactly. It's structured. Like there's a structure to the data.
Yeah.
So now I'm saying here back to our data. Okay, so this is our original data. Actually, original after we filtered out and we added the count and everything. Yeah, so now if we do grouping by, So let's say we want to, because not right here we have now all the ratings of the movies. So we have multiple like movie ID 1 that was rated by multiple users. So if we do group by the column movie ID, so what do we want to do with the resulting, like with the aggregated results, or like with the group by data? So the movie ID 1, for example, we have, let's say, 100 ratings with the movie ID 1. What do we want to do with all that data that we are grouping together? Well, after the group by function, we can apply, because the group by, as we said here, somewhere here, yeah, it's going to return a data frame of type group data. So if we apply an aggregate function to it, it's going to be, this aggregate function is going to be applied to every separate group. The reason here we applied the aggregate and it worked on the full data frame is because the full data frame was one group. So here, after we group by the movie ID, we're going to get multiple groups. For every movie ID, for every unique movie ID, we're going to get a group with multiple values. And then we can apply some aggregate like processing to it. And in this case, the processing we're doing is the average of the column rating. So this is the average of the column rating per group, because we did the group by based on the movie ID. And this is an aggregate function of that group. And we're even going to give it an alias of average rating. So this whole thing is that, like, we're not just specifying a column that does an average of the column rating, we're also giving it an alias name. Because the goal here is to return a column at the end, but we can apply some functions to that column to process things on it. And alias is one of it, like changing the name of the column, basically, that will be returned. So what this will do is that it will give us, for every unique movie ID, the average rating of that movie. And these are only the movie IDs that has more than 20 ratings overall, because we filtered them out before. I'm pretty sure this is much simpler than keeping track of all the sum and the count and then dividing and getting the average rating. Okay, now we have this is our new data frame now. We called it the DF average movie rating, and it consists of two columns, the movie ID and the average rating. So now if we want to order by the average rating, we want to order by descending order. So in here, this is the data frame, order by, and we need to specify a column to order by, but we also can be processing that column before we order by it. Meaning we can call the descending value on it, like descending function on the column. And this whole thing is going to return a new column, which is the descending of this average rating. It's just a memory of process that we want to do. It's not actually doing anything. It's just going to be passed to the order by, and the order by is going to read this information and it will know what to do. So now if we do this, we'll get the movies based on the movie ID and the average rating sorted from the highest to lowest. Is everyone with me so far? There's still like one little step that I will do, and then we finish it at here.
Yeah, it's pretty easy.
Okay, so at this point, I'm going to create a new data frame from the data of the movies.csv. Similar way to using the Spark session read.csv, specifying the CSV name file and the header equal to true. And this will load the data. And let's have a look at the data before we do the join. So this is the data. And, you know, I want to see filter column movie ID. I think it was equal to 11, the one that we had a problem with. with like one of the examples that had. Okay, so you see it automatically. This is the movie that I think this is the movie that had the comma in it. Okay, actually, this. Is that the one? Like whoever was telling me about the comma. Well, they did have a movie ID of 11. Actually, this one also, like the big Lebowski had a comma. Okay, so you can see it processed the comma correctly based on the double quotations that it had. We don't have to do any extra processing. It already read the CSV file properly based on the standard of CSV, where it contained the comma of the actual element, because the actual CSV file included it. Like whenever a element has a comma in it, it started it with double quotations. And then here with the like loading to a data frame, it loaded it correctly. So here we have the title includes a comma, and that's fine. It wasn't separated like we had when we were doing the processing manually. So this is one of the extra benefits of dealing with like data frames. It already loads the data, cleans it up, filtered it, and makes it ready for us to use. So anyway, so here we have the data frame for movies, which has the movie ID and the title and the genre. And then we want to join. So joining is easy. We do it this is the average movie ratings, which is right here for every movie ID, the average rating. And we are joining this with the data frame of movies and specifying the movie ID as the key to the joining. So if we do this join, we're gonna get for every movie ID in the average rating calculation we did, the average rating, the title of the movie, and the genre. Now, if we sort by the average rating, these are our top 20 movies: Shawshank Redemption, Sunset Boulevard, and so on. So, any questions? We're probably going to go over this kind of again next time, and I'm gonna put you in breakout rooms to start. So the goal here was to redo what you did now when you propose few things, but that was a bit of a failure because it was more complex than I expected. But we'll figure something out for next time to exercise data frames. But I think they will be similar to deal with than RDDs. Okay, I will upload this to Leah in case I know I said like there's no assignments, and there's still no assignments, but if you like to go over this and like check it out to be prepared for next time, like please do. And that's it for today. If you have any questions, let me know.
All right, sounds good.
Thank you, sir.
Thanks.
Have a good day.
Wednesday.
Bye-bye.